welcome to today's webinar, Getting Started with AWS. Our presenter today is Dave Rockamora. Dave is a solutions architect with Amazon Web Services. He's based in Seattle, Washington, and on a team that supports AWS's global network of technology and consulting partners. Dave works to help partners and their customers build exciting things with AWS. Dave's background is in consulting on technology systems for media and entertainment, financial services, and casino gambling. Dave, welcome. The floor is now yours.
Great. Thanks, Ryan. Hi, everybody. Thank you for joining me for this webinar about getting started with AWS. Let's see. So we'll go over what we're going to cover today. So first, we're going to go through, just really the first steps that you might need to do when you're, just getting going with AWS. So how to sign up for an AWS account, how to create an IAM user and enable multi-factor authentication to secure that account. Then we'll go over launching and connecting to EC2 instances. EC2 instances are virtual machines or servers in the cloud. Later we'll cover how to back up and restore those EC2 instances so you could run critical workloads on them. And then we'll take a look at the simple storage service to store and serve files. Finally, we're going to take a look at some of the billing tools to visualize AWS costs and set billing alerts so that you can sort of control the spend that you're doing inside of your AWS account. So, before we get started with the hands-on demo and technical stuff, I think we should talk a little bit about, I like to talk a little bit about what cloud computing is and how AWS sees cloud computing. So, we define cloud computing as the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. And I think this is pretty important, to understand when you're getting started, especially even for this webinar. So, what do we mean by on-demand delivery? That's, when you request resources from AWS, you get them, pretty much just right after you ask for them. And resources could be things like a server, a computer, storage, networks, databases, things like that. And they're all delivered over the internet. So there's no data center to drive through or, no package to wait for it to arrive at your house or wherever your office. And then everything has pay-as-you-go pricing. So similar to how you might pay for water or electricity from a utility, you pay for compute resources from AWS as you use them. So for every hour of compute time, for every gigabyte of month of storage in certain services, things like that. So it might be a different way to consume IT services than what you're used to, but it's pretty convenient. Okay, so next let's talk about the free tier. So we asked this question in the poll at the beginning, just to see if anybody was familiar with this. So, all AWS services are building that utility pricing model, but we include some services for free, to a certain amount with every single account. So, most AWS services are included in some way within the free tier, and it's available for all new accounts. So, when you sign up for an account, like if you decide to sign up for an account today, you'll be eligible for the free tier, and certain services will be free for up to a year for you. There's also other kinds of services in the free tier that are free just perpetually. So month to month, you get so many requests of Lambda, for example, for free. So I also want to point out that everything that I'm going to show today can be done within the free tier. So you should feel free to give these things a try, with your new AWS account without having to worry about incurring a cost. There's more details about the free tier at aws.amazon.com/free, and we'll take a look at that page too. Okay, cool. So to gear up for the first demo, what I'm going to show is, how you would sign into an AWS account. So you can sign up through the website. It's a self-service thing. You will need a credit card, and there'll be a telephone verification. So like when you do that sign up, you'll get a phone call, from an automated system that's sort of proving that you're a real human. Okay, cool. Let's go over to the demo and take a look. All right. So here you're on the web browser. So first thing I want to show you too was actually this the free tier website, aws.amazon.com/free. So if you look on this website, you can sort of scroll down and you can see what's covered under the free tier. So top of line here, Amazon EC2, the Elastic Compute Cloud, provides 750 hours a month of Linux and 750 hours a month of Windows usage. So you can run a server on EC2 for free, for a month. Or for the whole year, rather, actually. We also include some other services like S3 for storage, RDS, Once you're getting started with AWS, it's a good idea to take a look at this free tier website to understand, what's covered under the free tier and what's not, so that you can plan and build projects around that if you want to stay under that free tier. Okay. So, on any page in the aws.amazon.com website, you can create an account. So if you don't have an account already and you're not signed in, it's really as easy as clicking this button up here. So when you create your AWS account, you can just say that you'll be able to say that you're a new user, and you provide some information like your email. You'll need to provide a set of password. You'll provide your billing address and a credit card. And through that process, there will be a telephone verification where an automated system calls you and says, "Hey, are you a real human or not?" And it'll ask you to put some numbers into the website based on the phone call. So once you have that, you'll have an AWS account set up, and you'll be able to log into the AWS console. So I'll just show you that real quick here. So once you have your AWS account created and you log into the console, you'll see this. This is a listing of all of the services for Amazon Web Services. And there's a lot of stuff in here, but we're just going to cover a couple of these today, and I'll dive through them and show you how they work. So if we go back to the slides right now, we can start getting ready to launch some stuff in EC2. Or rather, actually, I think what we need to do actually is the first stuff that we're going to do is create some IAM users. So when I create an AWS account, I like to do a couple things first to make sure the account's set up properly, to make sure that it's secure, to make sure that it's sort of ready for me to build other stuff and do other stuff inside of the account. So the user that you logged into the console with, when you create it, with the email address and the password you set during sign up, that's called the root account. The root account has access to do pretty much anything inside of your AWS account. It can create users, it can launch servers, it can delete things, it can change all kinds of settings. And it has pretty much unrestricted control and access to your account. So this is good for some things, but typically it's not really the account that you want to use when you're working inside of in your AWS account. So we have a service called Identity and Access Management, or IAM. It allows you to create users and manage groups of users in there, in the AWS account. The users and groups that you create within IAM can have policies assigned to them to do different things. So you might want to have an administrator policy set to a couple of users that will administer the account. You might have a user that just needs read-only access to check in on things. Maybe the CFO of your company will just need to look at the billing section of that. You can create separate IAM users for all these individuals and have policies assigned to them to restrict their access to just exactly what they need. So it's important to create IAM users for everybody that's accessing the account, and I'd recommend that you don't really use that root account for anything unless you need it like in an emergency. So another thing that's really important to do with new accounts is to enable multi-factor authentication. So this is something that's becoming a lot more common now, so you might have seen this before on different systems that you use. What it is that in addition to the username and password that you'll need to log into an account, you'll also need to provide a code from a multi-factor authentication device. So this could be an application running on your mobile phone, or actually a physical token that kind of looks like this cartoony token here. This really helps you, to prevent, stolen passwords or keyloggers, because you have to have the password and this code from this token. So you really have to have the token to be able to log into an account. It's pretty important to enable this for your AWS accounts because an attacker could use your account to launch things that could cost you real money, or could use your account to access the information inside of your account. You can kind of think of like your AWS account is kind of like, and having access to your AWS account is like having access to the actual data center where your servers and computers are. So you want to make sure that you take it seriously and secure that. So what you want to do is enable multi-factor authentication for all the IAM users in your account and for the root account, so that anybody that's going to access your account needs to use multi-factor authentication. All right, so now we can go to a demo and we can take a look at setting up a user in IAM and enabling multi-factor authentication. All right, so here we are in the console. This is obviously the same one that we just left when we logged in. So there's tons of services in here. Let's take a look at one called Identity and Access Management, or IAM. It's down over here. So we can see in IAM there's a bunch of different entities on the left: groups, users, roles, policies. Let's click over on users, and we'll create that first user that we're going to use to administer the system. So there's already a user in here. That's me, Bakamura. But let's create another one for the demo. So we'll call this demo. So you can give users names inside of the account. You might want to associate these with people's actual login names or what their real names are, Dave, Mike, whatever it is. And there's a checkbox here that allows you to generate an access key for each of those users. So when you're accessing AWS through the console, you're logging in with a username and a password. But there's other ways to access AWS too. We have all the services have an API associated with them, and you can access that through many different programming language interfaces. We have SDKs for many different languages. And there's also command line interfaces and third-party utilities that can access AWS. So if you're interested in doing some of those things, you might want to generate an access key. But if you're just using it for the console, you don't need an access key. So let's uncheck that for now. We can always create one later if you change your mind. Okay, so now we created this demo user, but we have this user that has no password and it has no access key, so you can't really do much of anything with it. So from inside, when we click on that user, we can see some detailed information about this user. And what we could do from here is we could create an access key if we wanted to, and then download that and give that to the user. Actually, we may as well just go through that just to show you a little bit how that might work. We just clicked create access key, and it created these credentials here. This is the only time I'll be able to see these credentials and get them from the website, so I might want to download them because you'll never get another copy of them again. AWS doesn't store those credentials for you, so it's pretty important if you're generating them here that you save a copy of them. To log into the console, we're going to need to have a password. So on the same page here, this is under the Security Credentials tab under this user. We can say Manage Password, and we can just create a new password. So let's just assign an auto-generated password. And then once again, that password would be shown here, and we could download it. This is the one and only time we'll ever get that password from this until we reset it. So it's pretty important to make sure that you keep a copy of that password for that user. Okay, great. So now this user has an access key and a password that could be used to access the account. But this user has no policies associated with it. It has no permissions, so it really can't do anything. But you know what? Before I set up that policy, I realized because this is an IAM user that has access to the account, I need to set up multi-factor authentication. So that's pretty straightforward too. On the same tab, we can see this multi-factor authentication device, and we can say Manage MFA device. So from here, we can provision a virtual MFA or a hardware MFA. If we set up a virtual MFA device, what's going to do is prevent this QR code, and if I have an application on my phone that does multi-factor authentication, I can scan it. A Google Authenticator is one example of an MFA application. There's many. I could scan that there and activate the MFA. I'm not going to do that for now because we're going to delete this user in a second, but that's how you would set that up, and I would strongly recommend you set that up for all of the users in your account. Okay. So now we have a username and a password, and we have an access key, and we have multi-factor authentication set up. That means the user could log in and use this account. But it doesn't have any permissions to do anything, so we need to set up some permissions. It has no policies associated with it. So by default, all IAM users start with nothing. They have no access to anything. So to be able to do something like this, we need to attach a policy. So under the permissions tab under the user, we can say attach policy and select from a listing of policies. So we have tons of different policies that might be good for different kinds of things. A pretty common policy that I might set up for an account that I'm using to work with would be administrator access. That allows me to do anything in the account. It's equivalent to having the root account access, but it's not the root account. But another one that's really useful is the power user access, which allows me to do everything except for to do identity and access management. So actually, if I'm doing a lot of work in the account and I need to create users for other people that are working in the account, I'll do administrator access. But after that, I might drop my access down to power user. You can add and change these later if you like. So once you attach that policy, then this user is good to go, and people can log in and use that user. So now you have an IAM user account that you can use to administer the account. Okay. Let's flip back to the slides and start doing the next steps, which we'll need to do to be able to launch EC2 instances. So there's a couple things we have to do before we can launch an EC2 instance. So EC2 stands for the Elastic Compute Cloud. It allows you to launch virtual machine servers that run in the cloud. We call them instances. There's a couple things we have to do as like prerequisites to be able to launch an EC2 instance. And it's basically like have credentials to log into the instance, and then open the security group firewall so that we can access the actual instance. So the first thing that you need to do that is to create an SSH key pair. So I noticed in the poll it was about 60-40 Windows to Linux as far as people's familiarity. So for the Windows people, this might be new, but maybe not. Linux people, I'm pretty sure you've heard of SSH, which stands for the Secure Shell. So SSH, it's a way of remotely accessing computers. It's pretty common in the Linux world, Linux and Unix world. We use SSH to access Linux instances running on EC2, and we use key pairs to authenticate to those instances. So a key pair is it's using public key cryptography. A key pair has a public key and a private key that are sort of associated with each other, and so a system that holds the public key can prove the identity of someone that has the private key to allow them to authenticate. So this is a little stronger than a password because there's more entropy in that. In this private key, it's a little bit more secure than that, and allows you to access those instances. So you can import your own key if you have an SSH key that you like, or you can have AWS generate one for you. AWS does not store the private part of the key pair. So just like those credentials, you'll need to hold on to that private key pair if you want to be able to access those instances. Now, if you're using, this is true in Windows and Linux. So I'll show you how to use this key pair to access a Windows host 2, which might be a little bit different than what you're used to. But no matter what kind of EC2 instance you're launching, you're going to need to be able to do that. All right, so let's flip back over to the console, and we can create an SSH key pair. Okay, so here we are. Let's go back to the list of all of the services, and we'll zoom in on EC2. So here we are inside of the EC2 service, and we can see some information about it. And I'd say, something that that I see new people with AWS sometimes are running into trouble with has to do with region selection. So when we were creating the IAM user, that's global. That'll work in any AWS region anywhere around the world. The IAM users are everywhere. But things like EC2 instances, key pairs, volumes, S3 buckets, those exist in one region and one region only. And so a region is a collection of compute resources that's in a specific geographic location. So if we click over here on this top right, you can see this region drop down that gets some information about the different regions around the world. So you might pick a region to locate your servers and your data closer to your customers or to your office, or you might pick a region to locate something in a certain location for compliance reasons. So like maybe you have to keep data in the European Union or the United States. There's some differences between the regions, but pretty much they're actually all the same. For the core services, all the stuff that we're going to do today will work in any single region. So I'm going to choose Oregon because I'm here in Seattle, and this is my favorite region. But explore them all and find your favorite. Okay, so it's really important to pick that region and the reason is because what I'll see people do is create a bunch of things, log out of the console for a couple of days, and come back, and they can't find what they did. And that's probably because they're in the wrong region. So when you get started doing anything in the console, make sure you check which region you're in. All right, now we're over here. Let's go create a key pair. So in the EC2 dashboard here, we can see a bunch of different options here on the left. One of them here is key pairs. Let's click on that. So I already have a key pair that's hanging out in here. But we can create another one. So this is where I would click Create Key Pair to create a new one. I would click Import Key Pair to import an existing key pair. But let's just make a new one. And we'll call this Live Demo. So this creates an SSH key pair. Amazon's going to store the public part of the key pair, and it'll download the private part of the key pair here for me. I'll need to hold on to that and make sure that I keep it because AWS does not store the private key. It's up to me to make sure that I have that to be able to access the instances. All right, let's go back over to the slides and take a look. We're going to talk about the next step here, which is going to be to create a security group. So security groups are like the firewall that's around the EC2 instance. If you're familiar with firewalls from working with on-prem infrastructure, or other things, the firewall protects the instance from network traffic. So by default, security groups block all the traffic that's going into the instance, so it makes sure that nothing can connect to it. It's up to you to choose which protocols and ports to open. So protocol being something like TCP or UDP, And you can choose the port ranges, so 22 for SSH, 3389 for RDP, other kinds of ports that are open. You can pick individual ports or you can pick ranges of ports. You also get to choose who the ports are open to. So you can create rules that use CIDR notation for networks or groups of IP addresses. So if you're not familiar with CIDR notation, it looks like an IP address, four numbers separated by dots, and then a slash and another number, which represents the size of the network. So 0.0.0.0/0 is the entire internet, basically, allowing access to that. And then something with an IP address with /32 allows just an individual IP address to access. So you can also create security groups for other EC2 instances. So a pretty common thing to do is, like, let's say you have a series of EC2 instances that are your database servers, and a series of EC2 instances that are web servers that are accessing those database servers. You can create a security group on the database, a security group rule for the database server security group that allows access from the web server security group, so that you know that any instance in there can access the other instances. So security groups are really important for protecting EC2 instances because it limits the network traffic that's allowed inside of them. So we need to have a security group to launch an EC2 instance into. So let's create a security group and see how that works. So go back over the console here, and we can create a security group. Okay, so here we are in the console, and so we can see security groups here on the left. So we can click over to that. Now, once again, I always want to double check to make sure I'm in the region that I expect. So if I'm working in Oregon, I want to make sure that this says Oregon here. Otherwise, I can create a security group in a different region. And then when it comes time to launch my instances, I won't be able to find it and be quite confused. So it's pretty straightforward. We can just create a security group. We have the ability to give it a name and a description. This is useful for later if you're kind of trying to come back to this and say, what was that security group for? You can write some notes to yourself here for the future. For security groups, we can assign inbound and outbound rules. We'll make inbound rules so that we can create a security group that will allow us to remotely access the servers the instances that are launched inside of it. So let's add a rule here. So once again, we can pick, just by filling this out, we could pick, the protocol, the port, and the range. There's also some sort of pre-built handy things here. So let's do an SSH port. So this is just going to pick, TCP/22, which is SSH. And for the source that we're coming from, we could type the ID of a security group in here if we wanted to link it to a security group, or we can use an IP. So I could just type a network in here using CIDR notation. I could pick anywhere, which would open this up to the world. Anybody in the world would be able to access this. Or I could pick my IP. And then what's going to happen here is that the console is going to try to guess what my IP address is. So it only opens up this security group to me specifically. It's really tempting to pick the anywhere option because that means that this would work anywhere you are. It doesn't matter. You don't have to think about changing the security group again. But the downside is that you've opened this up to anybody in the world. So anybody could be accessing your instance or trying to access it. I would try to, to pick something as specific as possible. So I would go with my IP. So the console will try to guess what your IP address is. It might be right, it might be wrong, so you might need to tune this. There's other resources that you might need to use. Check with your network administrator, figure out what your public IP is on the outside of your office or your internet provider to understand where you're coming from. Let's add another rule here too, so we can add additional rules. We'll add one that allows RDP to allow us to be able to access from Windows instances too. So once again, this wizard just sort of populated this 3389, and we'll have it do from my IP as well. Okay, so once that's done, we can say create this security group. Now that's up and running. Now in the future, if I wanted to make changes here, if I forgot to add a rule or needed to change a rule, it's pretty easy. I can just select the security group and view and edit the rules again. So if I want to just make changes to security groups, you can do that on the fly, whenever you'd like. Okay, cool. So now that we have the security group and then we have the key pair, we can start talking about how we're going to launch an EC2 instance into that. So let's go back to the slides real quick and sort of talk through some intro material around that. Okay, so EC2 is the Elastic Compute Cloud. And it allows you to launch virtual machines in the cloud. So we call those instances. So when you launch an instance inside of EC2, you have full control of what's running on that instance. The operating system, the software you install on it, the users, the data that's on there. AWS doesn't have access to your EC2 instances, and you have total control of what's running on those instances. So you really can customize them, however you see fit. Instances come in different sizes and different families and sizes. So you can customize the amount of resources that the computer has. So if you need more memory or CPU or disk, you can choose a different instance type to get that. When you launch an EC2 instance, you need to have a key pair and a security group to launch those instances with. Otherwise, you won't be able to complete the launch wizard, but more importantly, you probably wouldn't be able to connect to the instance. So EC2 is a really flexible way to run virtually any kind of software on top of AWS. And it's a pretty powerful building block, and we see people use this a lot to run applications in AWS. So let's go over to the demo, and we can launch some EC2 instances, and we'll connect to them. Okay, so let's scroll over here on the left and click over on instances. Now, there's 2 instances running in here already, and we'll get to those in just a moment. But in your account, you probably wouldn't have any instances in here. So the first thing I want to do again is check to make sure that I'm in the right region. Yep. Still in Oregon, which is good. And I can just click this blue button here to launch an instance, and that brings up the launch wizard. So the first step to launching an EC2 instance is to pick the Amazon Machine Image, or AMI. Some people pronounce this AMI. I prefer AMI. The AMI is like the starting image, the base operating system for the instance. It sets it has the default software installed on it. And it's what the instance will sort of come up and have running when it begins. So you can see in this list, there's many different options available. There's Amazon Linux, there's Red Hat, SUSE, Ubuntu, and there's many different flavors of Windows that you can launch. There's even more there's more AMIs available on the marketplace. So AWS partners can can list and sell software products, different operating systems, different configurations of software running on AMIs. And there's also a whole slew of community AMIs, so people that have contributed an AMI that anybody could use that you can find and launch from there. If you're working in AWS a lot and you're customizing the stuff that you're creating, and we'll go through this a little later, you can create your own AMIs. So if you wanted to build an AMI about your perfect web server, database server, whatever, you can build an AMI and have that there. So for the purposes of this demo, well, I guess one more thing here too. It's pretty important. The free tier only covers certain kinds of things, and that comes down to the AMI. So you'll see that some of these AMI choices say free tier eligible. If you want to stay within the free tier, you need to make sure that you're picking an AMI that says free tier eligible. So there's a bunch of selections for Linux and Windows there. Just make sure you're picking the one to stay in the free tier. For this demo, let's just launch Amazon Linux. So next we get to pick the instance type and family, so the instance size and the family that it's in. And there's a whole slew of choices here. So you could pick instances that are customized for compute. You could pick instances that have special features like GPUs, different kinds of storage configurations, all kinds of stuff like that. This is how you would customize the computer to get sort of the performance out of it that you need. You can also see this list here. This has a bunch of different instance types that are available that you can use. If you want to stay within the free tier, you want to choose this instance type called the T2 Micro, which is the only one that's eligible for the free tier. This is actually a pretty decent computer. You can do a lot of stuff with this. So let's select that one, and we'll go to configure the instance details. So this has a bunch of advanced settings that you could use on this page. So if you wanted to change different ways about how this instance launched, or some settings that it might have, inside of it, you could change these here. One thing that you should look out for, when you're launching instances in your account that you're going to connect to over the internet, is to understand the setting here, auto assign the public IP. So without a public IP, you won't be able to connect to the instance because it won't be addressable over the internet. So you want to make sure that's enabled. So in certain circumstances, like in your account, it'll probably be set just the same way here as here in my account, where the default will be to enable that. But if you have customized your AWS account, you might need to change this to make sure that's enabled. If you curious about that, you need to take a look at your network design to make sure that that's set up right. So talk to your network administrator or work with AWS to figure out the right way to do that. So we can say add storage here. Okay, so the next part of this is we're going to add some storage. So this is the hard drive that will store the operating system for the computer that we're going to launch. There's a couple settings in here, and we can talk. I'm going to talk a little bit about this later. This is accessing a service called the EBS, the Elastic Block Store. So you can do things like change the size, the type. I'll talk about that a little bit later. The defaults are usually fine. Finally, we can tag the instance. Tagging is a way that we can organize instances, like by giving them names or other information that we can use. So let's just call this one demo. We'll call this live demo, so I don't get it mixed up. So that'll be the instance name. It'll help me find this later, when I'm working with it. All right, now here we go. We get to pick the security group that we launched the instance into. So let's select an existing security group, and we can select the one that we just created. So demo for demo servers. Sounds like a pretty good security group. So by selecting that, this instance will launch into that security group, or into that security group. Okay, so finally, we've reached the end of this wizard, and it's going to give us a big review of everything that we chose. And so we have an option to review this, and if we want to go back and change stuff, we can. But things look pretty good to me here, so let's click Launch. Okay, so now it's asking me to tell it which key pair to associate with this instance at launch. So I'm going to pick a live demo, which is the key pair I just created. And before I launch it, I have to say I acknowledge that I have this key pair, otherwise this won't launch. Because really, without this key pair, you will not be able to access the instance. So if you get to this point and you realize that you don't have that private key anymore, then you need to create a new key pair here, because you won't be able to. AWS doesn't store that private key, so it's up to you to keep track of it. So let's click Launch Instance. All right, so now the instance is launching, so we can go back to. I'll click on this instance name, and we can see it spinning up. So this instance is in a pending state right now. It's starting. I think typically you can expect to see an instance launch typically in under 5 minutes. But because we're on a schedule here, I took the liberty of launching a couple of EC2 instances before this started. And I'll just show you how to connect to those. I launched one that's a Linux instance and one that's a Windows instance, so we can see the differences about how to connect to each one. Okay, so for the Linux instance, connecting to it is pretty straightforward. We can just SSH to it. So if we select the instance here, we can see some information about what it's doing and how it's running. And it has a public IP address and a public DNS name. Let's just take that and copy that. Now, I'm on a Mac, and I know there's some people on this webinar that are using OS X, so this will probably be familiar. So I'm going to just connect to it over SSH using the terminal. If you're on Windows and you want to SSH to a Linux instance, then what you need to do is use PuTTY. And there might be a couple of extra, PuTTY or another SSH client that runs on Windows. There might be a couple of extra steps for you, because you might have to convert the key from one format to a format that PuTTY will understand. This is documented in the EC2 user guide. There's a whole section about what you might need to do to use PuTTY to access the instance. So this goes over converting the key and configuring PuTTY to do that. If you're on a Mac or a Linux computer, it's a little bit easier. What we can do is on my desktop, in this desktop here, I have this PEM file as the private key for this instance. So what I can do is type in a command to connect to it. So this is going to connect. This is going to use that key pair as my identity. It'll log into that EC2 instance. The username on this type in this AMI is EC2-user, and when I log in there, I'll be connected to that Linux instance. So here I am on that Linux instance. This just looks like anything, like any other Linux computer you might have seen before. You can customize this and configure this however you want. Let's install a web server on this instance. We can do kind of whatever we want to do here to use this instance and set it up just the way that we need it to be. Okay, so that's pretty good. Now that's all set up. But if you're not using Linux, you're not running Linux instances inside of EC2, how do you do the same thing with Windows? So, for Windows instances, you still need to launch them in the same way. You'll still need to have a key pair associated with it. You'll still need to do the same launch as you're just launching with a different AMI. But you can't use SSH to SSH to a Windows computer. So to be able to access this, you need to get a password. And what we do to allow you to do that is we have a functionality that's built into the Windows AMIs that launch in the launch EC2 instances that allow us to retrieve the password from the instance. So all we have to do is right-click on an instance that's running Windows and say get Windows password. And then from there, we have to provide the private key that we use to launch the instance. So we'll provide this key, and then we'll say decrypt password. And this will provide us with, this is the password that we can use to access this Windows instance. So once we have that information, the DNS name, the username, and that password, we can use remote desktop. And I've already pre-configured this here to connect into that instance. So we'll say OK. And ta-da, now we're inside of a Windows instance running on top of EC2. And we can do the same kind of things. We can install software, we can customize this, we can change this instance to make it set up in a way that's going to work for us. So for the time being, let's just disconnect from that. And now let's go back to the slides and talk a little bit about storage, for EC2 instances. So, a little bit behind my slides there. Okay. So, we mentioned this because when we saw this during the launch wizard, Amazon EBS, or Elastic Block Store. EBS provides persistent block storage for EC2 instances. So block storage is something that you might be familiar with, like a disk or a SAN, something that you need to create a file system on to be able to really use. So with EBS, you can create volumes that are as small as a gigabyte and as large as 16 terabytes. And you can actually create many of those and attach them to an instance. So if you really need a ton of storage, it's totally possible. EBS is available in several different types, so that have different performance and cost characteristics depending on the workload you have. You can also create snapshots of EBS volumes. So if you want to make a backup or keep a version of an EBS volume to see what it looks like at a point in time, you can create snapshots. That's pretty similar to like some SAN technology if you've worked with a SAN before. So when it comes to volume types, there's a couple of different sort of flavors of EBS that's available for you. There's two flavors of SSD, solid state disks, general purpose and provision IOPS. And there's two flavors of magnetic storage, throughput optimized and cold HDD. So, but on the SSD side, the general purpose SSD is kind of a great mix of cost and performance. It provides pretty much the SSD kind of capabilities that you'd expect to see out of a sort of server class SSD hardware. Pretty good IOPS, pretty good performance. It has a little bit of a variability to the IOPS that it provides, depending on what's going on. So for a sustained use workload, like a relational database that needs a ton of I/O performance, at like a very high amount with a very low variance on that performance, you might want to look into Provision IOPS SSD. So it's also a solid state disk, but it allows you to dial in exactly the amount of IOPS that you need, for that for that disk drive. Provision IOPS is a lot more expensive than general purpose SSD, so but sometimes it's a good fit for certain kinds of workloads. On the hard disk drive, the spinning disk to magnetic disk side of the equation here, we have throughput optimized hard disks and cold storage. So throughput optimized HDD is pretty good if you have something that's going to be streaming data off of the hard drive. So something like, think about a data warehouse that's doing columnar data store on the disks, or maybe you're streaming data in and out of some disks, and you need a cost-effective way to do that. Throughput optimized HDD might be a good choice. The cold HDD is really good for infrequently accessed data. So if you had like a big set of data that's kind of infrequently accessed, but you need a really sort of low-cost place to store it, cold HDD might be a good choice for you. Now that might look like a lot of choices, and if you're just getting started with AWS or you're really not sure which one to pick, let me just tell you right now, just choose general purpose SSD. It's also sometimes called GP2, that's the API name for it. GP2 is really the best mix of price and performance, and in my experience, it's sort of workable for almost any workload. This is probably the right one to pick if you're not sure. The nice thing is, though, is if you don't have to commit to using GP2. So you could launch an instance using GP2 or launch a volume using GP2. If it looks like it's not working out after a couple weeks, like you need more performance, you need less, you need a different kind of performance, then you can actually just create a snapshot of that and create a new volume in one of these other types to sort of achieve that. So my advice would be to don't stress out about this and just pick GP2 for now. All right, let's go back to the console and we'll do a couple demos around EBS real quick. Okay, so here we are in the console. We're still in Oregon. To make sure that's okay, and we have our instances running here. If we scroll down here on the left side, we can see a section of the EC2 console for Elastic Block Store, EBS. So let's go over to volumes here. And look, there's actually already some volumes running in the account. So these are the root drives for the instances that are running in the account. And there's one that's just hanging out here since last April. Whoops. Let's create a new volume right now, and we can attach it to one of the instances. So creating a volume is really straightforward. All we have to do is we pick the volume type. So there's the different types right up here. We can pick the size. Let's make one that's 10 gigabytes so that we can install some software on it. And we pick the availability zone. We didn't really cover this, but inside of each AWS region, there's availability zones that are like, you can think of them as data centers. And EBS volumes will need to be to exist in the same availability zone as the EC2 instance that they're attached to. So I noticed the other EC2 instances are in 2A, so let's just use 2A. I can take the opportunity to restore this volume from a snapshot if I want, and I can optionally encrypt this volume, if I needed to. But we're not going to do that. We'll just create basically a big empty volume that we can use. Okay, so that's in the process of being created right now. That takes really no time at all because there it is. It's up and running. Let me get some information about this. If we wanted to use this volume, we need to attach it to an instance. So we can say actions, attach volume. And then we could pick an instance, here. So we could attach this to our demo Linux instance. Okay, and we say attach. So from there, like within a minute or so, that volume will be attached to that instance. If we wanted to use it, we would probably need to log in, put a file system on it, mount it, load our data onto it. So once that's up and running, if we think that's when that's all good, if we ever need to make a backup of that volume, so we'll say we've customized it with a bunch of data and software, and we want to make sure we have a good copy of it, so we can go back to it. You can say actions and then create snapshot, and we can later on use this snapshot to restore a new volume from it. So we'll say test snap, and we can say create here, and the snapshot is being created. So we can go over here and see a collection of snapshots. Actually, look, it's already done because there wasn't a lot of data on it, as it turns out, because we haven't used it yet. But there's the snapshots we have, so we have these backups, for the future. So that's really good for making the EBS snapshots are great for making backups of data that's running on an EC2 instance. But if we want to back up the whole configuration of the computer so that we could launch it again, say we installed a web server on that Linux box before. What if we wanted to make an image of it so we could launch it over and over again? What we can do is create an AMI. So let's go over to instances, and we'll pick that demo Linux instance. This is the one I customized earlier. Making an AMI is really straightforward. You basically just go to the actions and then image, and we can just say create image here, and that starts this little wizard here that will describe how we created an AMI. So we can give it a name, we can give it a description. We have this opportunity to customize the storage configuration on there. So if we wanted to add more storage, in the image that's going to be used to create this, we could do this here, and then we could say create image. Once that's done, this will cause the computer to be rebooted. So keep that in mind. You might not want to do this on a server that's running, But once you have that, you'll have this sort of gold image that you can use to duplicate that. So if you put a lot of effort into customizing the instance, you can create an AMI from it and launch it over and over again and have duplicate copies of it. So that's how so that's a pretty common way that people use to sort of do a lot of work and stage it and back it up so that they can repeat that work quite easily in the future inside of EC2. All right, cool. Let's go back to the slides and we can talk about another storage service that's really useful for customers on AWS. So let's talk about Amazon S3. So S3 stands for the Simple Storage Service. There's 3 S's. It just had its 10-year birthday earlier this year, so happy birthday, S3. So S3 is different than EBS. S3 is an object store, so it allows you to store binary objects. Think of them like files or basically other kinds of data that's organized in an object. You can store pretty much any amount of data inside of S3. Each object, the minimum size of an object is 1 byte, and the maximum size of an object is 5 terabytes. And you can actually store as many objects as you want. So, customers could be storing petabytes and petabytes of data inside of S3 if you want. S3 is designed to be highly scalable, so it can support really any amount of data. It can support any amount of simultaneous users or computers accessing that data. So it's a pretty scalable system that's suitable for most object storage. Encryption is available for S3, so you can encrypt the data that you store in there. There's many different options. You can have Amazon do the encryption and manage the keys. You could manage the keys. You could use some of our services like KMS, the key management service, to do that. And some customers choose to encrypt the data before they even send it to S3, so it's encrypted there. When you're storing data inside of S3, it's stored in the region that you choose. So if you want to store your data closer to your customers, if you want to store your data closer to your or in a specific region for compliance reasons, the data that you choose to store, the region that you choose to store your S3 objects in, doesn't change. We won't move the data for you, so you can be assured that it'll be in the right place. You can apply permissions to objects. So by default, everything in S3 will be private, so no one else will be able to access it. But you can open that up to share it with other AWS accounts, or to publish stuff on the internet, so like serve images for your websites or software for your website. Right there, you can customize it object by object. And S3 is really easy to access. So we're going to go through using the console, but there's also command line tools and third-party software that integrate directly with the S3 API to store data. It's actually pretty common. You might be surprised if you're using some backup software today. It probably has an interface that allows it to store data on S3. So it's worth something to take a look at. S3 is a great place to store backups. All right, let's go over to the. There we go. Sorry. Let's go back over to my console, and I can show you a little bit about how we're going to store some objects in S3. So let's leave EC2 for now, and we'll go back to the main list of services. So S3 is under here in the section called Storage and Content Delivery. Let's click on that. So inside of S3, the top level organizational thing inside of S3 is called a bucket. So a bucket is a place where you store the objects inside of there. The bucket is the thing that actually exists in one region or other. So let's make a new bucket that we can use, for storing some data for this demo. So when I create a bucket, I get this option to give the bucket a name, and I can pick the location. So I can pick any place in the world where I'd like this bucket to be. Once again, we'll pick Oregon because I just like Oregon. I don't know what it is. And let's pick a name for the bucket. Let's just see if we can pick this name demo and see how that works. Oh, okay. So we got an error. So one of the maybe unique things about S3 to keep in mind is that the namespace for buckets, so like the name of the buckets, it's global. It's shared by all customers. So very common names like Demo or Dave, for example, are probably not available. So we're going to have to pick, a sort of a unique name for the S3 bucket that we're creating. Sometimes it's surprising what names you can get, but let's just play it safe on this webinar, and we'll use our like today's date in here. So it's 2016-06-26. Okay, and we'll create this bucket. I'd be surprised if someone has taken that. That's unbelievable. Wow. We'll just add some extra numbers here. All right, that's much better. Okay, so now that's our very unique bucket name that we have there, and it's in Oregon. So yeah, that global unique namespace is something that can sometimes be a challenge. So now we have this bucket, created. There's actually, if we go inside, we can click inside of it in the console, and we can see that there's nothing inside of that bucket. So let's upload something. Now you might want to use, you can use the console for doing some uploads, and we just click upload, that button up here, and then click add files. And we can pick files. This is a photograph that I took a couple years ago that I'm a pretty big fan of. You can select that and say start upload. Uploading little bits of data to the console is pretty fine, but if you're going to be moving a lot of data in and out, I'd recommend you take a look at the command line interface to do that, or start looking at some third-party tools, partner tools that can interface with S3. Now that object's there in S3, we can take a look at the permissions around it. So by default, this is private. No one will be able to access it. So if I clicked on this, the link to the bucket says access the object. It says access denied, so I won't be able to access it. If we wanted to share this, to the public, what we could do is just right-click on that object and say make public. And what this will do is it's going to change the permissions on the object to be public. So now when we click on the link, what we'll see is we can see this photograph. So that's being served straight from S3. So you can see that this, S3 could be a pretty good way for you to, share objects, store any kind of object. You can keep it private if you want, like if it's your computer backups. But if you wanted to, say, store images for your website and serve them straight off of S3, you can absolutely do that there. Okay, so let's go back to the slides real quick, and we can talk about the last thing I want to cover, which is billing and cost management, inside of AWS. So, we've created a bunch of stuff in our account. S3 buckets, objects, EC2 instances. We're getting a lot of stuff set up in here. Something that new customers are often concerned about is, how do I manage and control my costs within AWS? And there's several ways that you can do that. There's several features that we have that can help you do that. Things like the Cost Explorer, which allows you to visually see what's going on in your account. We can also set alerts on spending limits. We have the capability to provide detailed billing reports so you can see exactly where your spend is coming from and maybe load it into another tool that you could use to analyze what's going on. And we also have consolidated billing. Consolidated billing would allow you to link a bunch of accounts together. So, like, let's say many people in your organization were using AWS. You can use consolidated billing to link that all together, so you only have one AWS bill to pay instead of having to manage many accounts. All right, let's flip over to the console, and we'll do this last demo here, which will be to cover some of the billing stuff we can do. So the billing services are actually in a slightly different place than the other services. It's not going to be in the main service dropdown. It'll be over here under your name. So the username that's used to log in. We can go to billing and cost management. Now inside of here, we can see information about our bill. Oh boy, a 3-cent bill. I'm in trouble. Just kidding. So we can see all kinds of information about the last bill that we had, and some other information about that. We can take a look at the Cost Explorer here. This is a useful tool for understanding like how your costs are changing over time. We can launch this and say, show me my EC2 instance over for the year. This account actually isn't super busy for me. I actually only did something here in April, and then I did a little bit of work here in July. But your account might have more. So you can use the Cost Explorer to understand where your costs are coming from and when they're happening. It can help you look back in the past and maybe help you plan for the future. Okay, the next thing I want to do is set a billing alarm, and I think this is something you should probably do in your account, as you're getting started. The worst things you want to do is sort of wake up, one morning and have like a bill from AWS that's a lot higher than you expected. So we can set an alert to send us an email whenever our bill goes above, say, $5. So under Preferences in the billing dashboard, you can see there's going to be a checkbox, and in your account this will probably be unchecked, but you want to check this to be able to get that. So we can say Receive Billing Alerts. Once we have set that, once that checkbox is set up, we can set up an alert using a service we have called CloudWatch. So CloudWatch is like our general purpose monitoring and alerting system. And so billing metrics are one of the things that you can monitor with CloudWatch, and you can set alerts on it. So we'll say Create Billing Alarm. And let's just say, if my AWS account spend rises over $5, if my monthly charge is going to be more than $5, send me an email. And so we'll just put that in there, and we'll say, we'll add my email there. So now, when as people are using this account, or as I'm using this account, if the charge ever goes up to about $5, I'll receive an email, from AWS saying, hey, by the way, you're spending $5. This will ask me to confirm this. I'll have to reply to this email. So I'll just say I'll do this later. Okay, so I think it's really important to set those up, and it's also important to know you could set up multiple ones of those. So maybe you want to have an alert that goes on at at $5 and one that goes at $10 or something like that. You can make that customization, that change there too. Okay, so we can go back to the slides here and just sort of sum up what's happened today. So we covered how to create an AWS account and get started with the very first steps that you might need to do in that account. Create an IAM user, enable multi-factor authentication. We also covered launching EC2 instances and how we might connect to them. Then we took a look at EBS and how to back up and restore EC2 instances. We also looked at S3, which is a good way to store objects and serve them over the internet. And we took a look at the Cost Explorer and some of the billing alert capability so that we could monitor your AWS costs in your new AWS account. Okay, so with that, I might turn it over to Ryan for a second. What we'll do is keep those questions coming in, and we'll go do some live Q&A here in a minute. But I'll turn it back over to Ryan for some announcements. Yeah, so we have a question here about the regions. So can you explain more about the regions and why a customer is able to choose, one in the first place? Is it a question of governance? So, the people tend to choose the different regions in AWS for, I'd say, two main different reasons. One is to be closer to their customers. So if most of your customers are in Asia or most of your customers are in Europe or South America, you might want to pick a region like, that's closer to them, like Singapore or Tokyo in Asia, or Brazil in South America. That's one reason, so you can lower the latency to get to your customers. Another reason is compliance and data sovereignty. Certain compliance requirements require that data is stored in the same country. The European Union is an example of that. You must store data about European Union citizens within the EU. So we have a region in Frankfurt, for example, which is a great choice for that kind of thing. We try to make the regions as similar as possible. There's sometimes some differences with feature parity, and there's sometimes some difference in cost. So some regions might cost a little bit more than others. But I would say the two main reasons that people are picking the different regions is to be closer to their customers and to meet with some compliance requirements. So let's find another question here. So here's a good question about the Windows stuff. So when you launch a Windows instance, how does the Microsoft licensing work? So the instances that were the AMIs that were available in that list there, the Microsoft license, the Windows license, is included in the hourly rate for that license. There's also options to bring your own license if you have Microsoft Windows into AWS, where that might be worthwhile. We have more information about that on the website. If you go, you could search for Windows licensing on AWS, or go to aws.amazon.com/windows, and it's a ton of information about in what scenarios could you use could you move licenses over to Windows, and what options are available to you for paying for licenses like that. There's another question here about security group rules, so inbound and outbound security group rules on EC2 instances. So when I said that, so the security group rules, it does cover both inbound traffic and outbound traffic, from the instance. The ones that I configured were just inbound only rules, so I was only allowing certain ports of information in. For the outbound, you can additionally set outbound rules if you want to control what kind of traffic is allowed to leave the instance. By default in a security group, everything's allowed to leave the instance, the security group. So there's typically, unless you're in like a high security environment, there's really not usually a need to adjust that. But if you really want to control how your instances talk to each other, then you might want to add some outbound security groups as well, security group rules as well. Let's see if we can find one more question. So the last question here is, does the AMI that you're selecting, change the price of the instance? Is Red Hat more expensive than Amazon, for example? So yeah, some of those AMIs, they include like an hourly rate on top of the EC2 time for the license. So the Microsoft licenses that I was talking about for Windows were another example of that. So since the operating system license or the software license is included, in the AMI, the hourly rate, could be higher. That's the same with, there's a ton of software available on the AWS Marketplace that has the same kind of model. So if you're using there's things like appliances for doing security or storage or a CMS that are available on the Marketplace, and the license for those is included in the hourly rate. Okay, so that's pretty much all the time we have for questions today. Thanks so much for coming to the webinar. Really appreciate it.